Assalamu alaikum, this is Yasin Rajput, and today we will discuss all the reactions, conditions, and reagent for carbonyl chapter. Now, let's start with the first equation, and that's very important. This is basically primary alcohol, okay, bacho? So, this is primary alcohol, and now how can we convert primary alcohol into the aldehydes? You can see that this is the aldehyde function group, okay? Now, you have to remove hydrogen from the OH function group and the hydrogen from the same carbon atom which is attached to the OH. So when you remove this hydrogen and this hydrogen, you will end up with the double bond between carbon and oxygen. The rest of the things you would have to write down as it is. Okay, so now you can see that by using this trick you can convert the alcohol into the aldehyde. So the type of reaction is oxidation, and this is the reagent that we are using, and that is basically potassium dichromate, acidified potassium dichromate, and this is heat and distill off. This is important, heat and distill off. So don't write down heat under reflux, you have to write down heat and distill off. Now let's talk about the next equation. You can see that this is the secondary alcohol. Why this is secondary alcohol? You can see that this carbon is bonded to the two carbon atom directly, and apply the same trick, remove hydrogen from the alcohol function group and remove the hydrogen from the same carbon atom. So you will end up with the ketone. Now when you remove this hydrogen, you get the double bond. So that's how we can convert the secondary alcohol into the ketone. Clear? So this is the function group of ketone. Now, we are using the potassium dichromate, acidified potassium dichromate, and the type of reaction is again oxidation. And this is the condition and heat under reflux. Now, we can't oxidize the tertiary alcohol. This is the tertiary alcohol. We can't oxidize the tertiary alcohol. You can see that this carbon is not attached with any hydrogen. So we can remove this hydrogen, but we can't remove we don't have the hydrogen. So how can we make the double bond over here? So this can't be oxidized. So this is the quick revision for all the reactions. So I'm not explaining in depth. So you just need to learn by heart the type of reaction, conditions, and the reagent. Now, this is the aldehyde. You can convert the aldehyde into the alcohols again. So the same concept applies over here. You just need to break the double bond and add the hydrogen over here and the hydrogen over here. So this lithium aluminum hydride in dry ether you can use. This is the basically reducing agent. It provides the hydrogen. So one hydrogen comes over here and one hydrogen comes over here, and this bond would be broken down, and you will end up with the this primary alcohol. Clear? So this is the type of reaction which is reduction, and you need to write on heat, and this is the reducing agent, lithium aluminum hydride in dry ether. You can also use sodium borohydride, or you can use nickel plus hydrogen. Likewise, you can convert the ketone into the alcohols. Okay, so you can convert the ketone into the alcohols. Let me write down the hydrogen over here. So when you use the lithium aluminum hydride, this is the reducing agent. It provides the hydrogen. This bond would be broken down. You need to write down hydrogen over here and the hydrogen over here. Clear? Like this, you will end up with the two hydrogens that are coming from this lithium aluminum hydride, and you will end up with the secondary alcohol. So when you do the reduction of the ketone, you will end up with the secondary alcohol. So now let's talk about the next part, which is the you can convert the aldehyde into the carboxylic acid. So definitely you have to use the oxidizing agent. Okay, so we can use the four oxidizing agent. The first one is the potassium dichromate, and then potassium manganate, and then tolerance reagent, and then Fehling solution. Okay, so this must be acidified. Okay, this must be acidified. Clear? This must be acidified. Now, so the color change would be orange to green. For the potassium manganate, it would be purple to colorless, tolerance region silver precipitate, and for the Fehling solution, it forms the brick red precipitate. Okay, that's how we can convert the aldehyde into the carboxylic acid. So what is basically the type of reaction? So this type of reaction is oxidation, and this is the acidified potassium dichromate. You can write down in words acidified potassium dichromate and heat under reflux. Clear? So you can see that by using this oxidizing agent you will end up with the oxygen, okay, and this would be added over here and you will end up with the carboxylic acid. So I'm not explaining in detail. So the next reaction is how can we convert aldehyde and ketones into the hydroxynitriles? The most important reaction it is. So you can see that this is the C double bond O function group. Okay, so by using this mechanism, nucleophilic addition mechanism, uh, you will end up with the hydrogen over here and CN over here. So this is nitrile and this is the alcohol. This becomes alcohol and this becomes nitrile. Okay, so what's the reagent for this reaction? The reagent for this reaction is sodium cyanide, okay, in dilute HCN. Clear? And what would be the condition? Heat under reflux. And what's the mechanism? The mechanism is nucleophilic addition. So the most important condensation reaction of the carbonyl compound is that with 2,4-DNPH. Okay, now you can see that this is the 2,4-DNPH. This can react with the carbonyl, so it means that it can react with the aldehyde or ketones. So uh, I'm not explaining the like the mechanism. You can see that this like the water is being removed and you will end up with the double bond between the nitrogen and carbon. Okay, so you will end up with the hydra zones. So this becomes 2,4-DNPH, but the name is 2,4-dinitrophenyl hydra zones. So you will end up with the orange precipitate. So if you get the orange precipitate, it means it confirms the presence of carbonyl functional group. And